You recording?
Yeah.
Okay, here we go. A few examples here. We'll try and keep this brief. This video will be on Schoology for your reference in the future. This is just to wrap up, just a couple more questions, maybe help boost your confidence a little bit. Write this as an exponential expression. Write this expression in exponential form. Write it so that it doesn't have a radical, basically is what they're saying. So you can see we've got the radical down here in the bottom. It's a simple square root, right? So we know that square roots, come on smartboard, oh boy, oh boy. Square roots are what? As powers, what are square roots? 1/2. Right, half powers, right? Whatever number is here is the denominator of the exponent. Whatever is here is the numerator of the exponent, but this is just 2x. And this is a square root. We don't write the 2 there, but this is a square root. So I know that the exponent is going to have a 2 as its denominator, and the 2x that was under that square root doesn't have an exponent, so it's, oh God, it's, okay. Not a good example when the camera's rolling, but you guys get the idea. So we have, this should, let me see if I can fix this. This should say 2x, probably not going to work. No, 2x to the half power, there we go, close enough. In the bottom of the fraction. Yesterday we said if you want, you don't have to have powers in fractions if you don't want, right? There are other ways to write this. If I don't want this to be down here in a fraction, what do I have to do? What can I do? Similar to, where were we? Similar to this problem. What can I do if I don't want to have a fraction? Here I made it a fraction, whereas before it wasn't. What makes this fraction appear is a negative exponent, right? So when you see a negative exponent, you know you can write it in the denominator. That same rule applies in reverse. If you don't want to write a fraction, if you don't want that exponent in the denominator, write it up top, only make it negative. Make it the opposite. So in this case, I can say that this is the same thing as 2x to the negative 1/2 power. And believe me, it might not matter now, but I'm not going to let you go into pre-calc, which you will then hopefully go into calculus without knowing this sort of stuff. Because there are things that you do in calculus, chain rules, differentiation rules, where negative exponents come around a lot. I'm telling you, okay? Because you deal with curves. Curves have exponents as a part of the function. So you need to be comfortable with this concept of if it's negative, it can be in the bottom. If you don't want it to be in the bottom, write it with the negative exponent. The rule works both ways. All right? These are the proofs that I'm talking about that you guys are going to have to do when you're in pre-calc, when you're in calculus, right? Very simple looking proof. It's a question of, are these the same? Okay? When you were doing proofs in geometry, it was you had to show your postulates and you had to go step by step by step. We don't make you justify what you're doing as long as what you're doing falls within, you know, the laws of math, the properties of mathematics. So my question is, are these equal? Notice the question mark, okay? There's a whole nother discussion about, you know, the approach to this. But basically, you can't take the square root of both sides. You can't add something to both. You wouldn't want to do that anyway. But the question is, can I simplify this, or can I break this down to the point where they are exactly the same? Are they the same? That's the question. That's what the question mark is. So let's take a look. What do we know? The way that this is written looks very simple, right? Can I write this as x, y to the 3 minus 2? Can I subtract these exponents? No. Why not? Different bases, right? So this is really, you know, what are we going to do here? Let's look over here. What can I do with this? I've got a fraction with an exponent, right? I have powers of powers. Now this doesn't have a power that's visible right now. Let's see if this works. It's really y to the first, but because it's a fraction, I can bring this 2 and multiply it to both of these exponents here, distribute, if you will. Not that that's actually accurate, but it's like the middle of the board that's all messed up. That's what it is, it's weird. It's like right here, not so much here or here, but right here. That's from Tommy Boy. You guys ever seen Tommy Boy? Chris Farley, you ever heard of Chris Farley? You ever heard of David Spade? Go to whatever website you pirate your movies off of and you watch your free stuff. Go to it tonight and type in Tommy Boy and watch it. It's hilarious. Okay, anyway, going back to this. So we're multiplying 2 times 3 halves. Here's our margin work. 3 halves times 2, right? I need this to be a fraction. Multiply straight across. That's 6 over 2. What's 6 over 2? 3. So the top actually turns out to be x cubed. 2 times 1 is y squared. So yes, check mark. Yes, they are the same. Okay? Wanted to show you a problem like this just so you understand these types of expressions can be shown any number of ways. Okay? You can manipulate this 1,000 ways. Like this. So it's the same statement here. It's the same statement here if you notice. Y to the 3 halves, or excuse me, x to the 3 halves over y quantity squared. I'm showing you that here. I want to know, is that the same as this? I think we can stop recording at this point. Thank you.